So in the last class, we are discussing about the artificial neural networks code, and let us complete in today's class this one. Now, whatever the artificial neural networks in the previous class we have executed. Okay. Now, just I'm continuing from the last one where we have executed. I think everyone has even practiced, right? Yesterday's whatever the notebook I have shared, data set and notebook, which was uploaded in the Google Drive. So first you're going to have the business problem and later data exploration, data cleaning, and followed by data wrangling. And finally, we are going to have the input and output. After that, we are going to split the data. Once we split the data, now we are having the modeling. In the modeling, what we'll have, first one is design, second one is fit, third one is predict. Total three things will be there. Design, fit on the data, and predict. Total three things will be there. Okay. So first we are going to design the neural network. That is nothing but perceptron model, which we have already completed in the previous class. And here, next one is after completing the perceptron model and everything. Now we are going to work with the artificial neural networks. So in the last class, we have seen the how to work with the ANN models. Perceptron model. So in today's class, we are going to continue. Next one is called as ANN model. Now, what is the difference between the this one versus this one means? Again, same. In the neural network also, within the ANN model, what are the ANN model you are having? Okay. So the ANN model, again, we are going to do the design. After the design, we are going to have the fit on X train comma Y train. Then we are going to predict. We are going to apply the predict and we are going to do the evaluation. That is calculate the final RMSC. What are the RMSC is there? Train RMSC along with the test RMSC. So same logic we are going to do. That is first whatever we have done for the perceptron model, same thing we are going to do. First to design the neural network. Before designing the neural network, first only how we can know how many layers we have to add. Do we know that we have to add 10 layers or 20 layers or how many layers we have to add? Do we know first only means we don't know first we have to add the 10 layers or 20 layers or something. Then what we are going to do in that case, we are going to add only one layer. So here I'm going to create first a design of the neural network. This is nothing but design of neural network. Okay, in the design, already in the last class, we have discussed perceptron model. First, we are going to have the sequential, and within the sequential, we are going to add here input dimensions is equal to 4, units is equal to 8. What is meant by units is equal to 8? Input dimensions is equal to 4 means input layer has the 4 units, followed by 8 units. Why 8 units I have taken? The maximum number. That is the maximum number which we can have. That is nothing but 2 input input neurons. How many input neurons are there? 2 into input neurons. That is 4 here. 4 into 2. 4 into 2 is nothing but 8. That is the maximum. So here how many I am adding? 8. That is one layer. Followed by again single neuron. After the single neuron, I'm not having anything. So what is the difference between the last perceptron model versus this one? If you observe clearly, I'm copying this one from here to here. I'm just copying so that I want to show you both of the difference. Now, if you observe here, this is our perceptron model. In the perceptron model, what is the difference we have done? This is perceptron model. This is ANN model. Here, total how many lines are there? 1, 2, 3. In the perceptron model design, 3 lines of perceptron model. How many lines we are having here? Extra one line. What is that extra one line? Hidden layer. That's it. Out of here 3 lines, here 4 lines. Only difference is that. Here optimizer is equal to Adam, mean square error. Here also optimizer is equal to Adam, mean square error. And activation function is ReLU, uniform. ReLU, uniform. Extra what you have added? Here 4 and 1 is there. That is 4 neurons followed by 1 neuron. Here 4, 8, 1. 481. That is 4 neurons are connected to 8. 8 is connected to 1 neuron. Now, first I'm going to add design the neural network with one hidden layer. Only one hidden layer, guys. I'm not going to add the multiple with one hidden layer. After adding the one hidden layer, fit on X train comma Y train. I told you once the design was completed, fit on X train comma Y train. Next, predict. Next one is what? Predict on the X train. From that, you are going to calculate the train RMSC. Same codes. If you observe the previously, whatever we have done here for the perceptron model, same code. Model name was changed. Here P model I have used, there NN1 model I am using. The name I am changing. Fit on X train comma Y train, batch size is equal to 32, epochs is equal to 100. Same way, here also, same thing, where you are having the units is equal to 4. I mean input dimensions 4, units is equal to 8. Fit on X train Y train, batch size of 32, epochs is equal to 100. And then what dot predict on X train. Okay, what are the X train you are having? It is going to predict. Now, finally, predict on the train data, that is calculating the train RMSC, calculating the test RMSC. Same thing, as it is copy and code. Now, sir, but here, okay, if you observe the perceptron model, whatever we have executed perceptron model in the previous class. Now, first you have taken in the cell number 1, these 3 lines, cell 1. In the cell 2, you have taken the fit, okay, cell 2. In the cell 3, you have predicted on the train data. In the cell 4, you have predicted on the test data. Total 4 different cells you have used in the Jupyter notebook. Whereas when it comes to the ANN model, I'm using everything in a single cell. It is not compulsory to use the multiple cells now. I'm using just a single cell. Code is same only, copy paste only. Just I'm copying everything in the single cell. Now once I copy into the single cell, see, now again it is going to execute in the same way. Now earlier here, what is the error loss we have got in the perceptron model? 2,06,722. So I'm going to write here number of hidden layers. For number of hidden layers, I'm going to create one table and train RMSC. What are the train RMSC? In the second next column, test RMSC. Let me create one table like this. After creating a table like this, here number of hidden layers is equal to 0. Number of hidden layers is equal to 0. This is 454. Number of hidden layers is equal to 0. That is nothing but perceptron model 454. Whereas this one is also 454. Okay, which we got the 454 with 0 hidden layers. That is nothing but perceptron model. Now let us try with the one layer and let us cross check what is the train RMSA and test RMSA we are going to get. So if you observe clearly, starting first epoch has given the 1,15,000 error. That is MSC, not RMSC guys, MSC. Again, we have to apply the square root for this to get the RMSC. Now, if you observe second epoch reduced, third epoch reduced, like that it is reducing. Of 186, 164, 143, 124. Can everyone see clearly? One epoch, the error is reducing. 49, 44, 40, 37. Somewhere after that, there will be no much difference. So after 35th epoch, 30, till the 30, 28. Okay, 30, 30, 28 also. The number of, okay. After 28, again 20, 27, after that 26. Now here, the error slightly was increased 26 to 27, but if you scroll down, 25, 25 also available. Out of all these things, which is the least error? 25, right? Now, where you got that 25? In the 100 epoch you got, or before only you have got? Same 25 error, where you have received that 25. First 25, where you have received? In the 51st epoch itself, you have got the 25.80. Means, so for this particular model, to get the 25, how much epochs are required? 50 epochs is sufficient. Not even 100 epochs are required. Because in the 100 epoch, if you are getting the something differently, miss, okay. If you are getting a 10, 4 miss, okay. But Now see, what is the train RMSE and test RMSE? Train RMSE is with one hidden layer 5.39, 5.69 with one hidden layer. Now, what is the next step, sir? Try with the two hidden layers. This is one hidden layer now. This entire code again copy and paste here down. Let me paste here down. Now I'm going to create with the two hidden layers. NN2. What is my NN2 model means? NN2 means basically it is nothing but my NN2. Wherever NN1 is there, I'm replacing NN1 with the NN2. NN2 means neural network with two hidden layers. That is my meaning. It is not compulsory you have to use NN2 only. From my perspective, a neural network with two hidden layers. Now I'm going to add one more hidden layer. How to add one more hidden layer means just enter here. That is input dimensions along with the first hidden layer was added. From there, copy and paste. Now in this, no need to add the input dimensions. From here onwards, just you have to add the units only. How many units? So 4, 8, 8 and 1. So first input dimension 4. Hidden layer consists of 8 neurons. Again hidden layer consists of 8 neurons and output consists of 1 neuron. Input, hidden, hidden and output. Everyone is clear guys? Understood or not? Now whatever you have having here, that is NN2 is equal to sequential or everything, and finally from this again you are going to execute. Simple. Now automatically you will only tell at the end whether with one hidden layer is good or two hidden layers is good. You will only tell automatically. Sir, for example, assume here error was increased to 10.69. Let's take an example, guys. I also don't know what is the answer, but let's take an example in meanwhile. It will take time to execute now. For example, error was increased. Train RMSE and test RMSE both has increased instead of decreasing, increased. Then hidden layer, two hidden layers is a good option or bad option? This is P model. This is NN1 model. This is NN2 model. Now out of these, should I try with NN3? According to you, tell me, should I try with NN3 or not? Yes or no? Okay. So no need to try with the NN3 model also, because as overall error is increasing, as you increase the number of hidden layers, error is increasing means stop adding. Sir, for example, you got here 3, sir, 3.13. Then should I add one more layer or not in this case? Add. Why? Because error is decreasing. How many times the error is decreasing? Each time you add one layer. We also don't know which layer will give the best answer. It's pure trial and error method. Sir, but it will take time. No, sir, miss. Obviously, it will take time. Our requirement is always focus only on the end result. For the future data, accuracy should be very high. Completing the model in less time is not our aim. For the future data, we have to predict with the maximum accuracy. Always we should have the aim in that way. Is the points are clear, guys? Everyone? Yes or no? Now see, again I'm going to recalculate. Now what is the train RMS and test RMS means? Train is 5.14. Reduced or not reduced means reduced. Okay. Now 5.36. This is also reduced. Now you tell me, should I add or should I not add one more layer? Add or not add? Means there is no much difference, right? Since there is no much difference, though it is dropped also, there is no much difference. Only decimal values are changing now. If the main value changes means I have to add. Don't focus on the decimal. For example, if you make the round figure, decimal will not have that much of importance. Here, even in the epochs of so 25.8, I told you, in the last you are having the 25.6 also. Stop at the 50th epoch only, I told you. 25.8 to 25.6, there is no much difference. So just focus on the round number. Okay, don't focus on the much into the decimals. Is the point is clear, everyone? So with neural network of zero hidden layers is 454. With one hidden layer is 5. For two hidden layers also it is almost close to 5. So now in this example, there is no use of adding the one more hidden layer. Next, here everyone has to make a note. What is the note is? Mm. Everyone please write the notes. Okay. The notes is nothing but here, first one. We are having the train RMSC. If train RMSC equal to test RMSC. If train RMSC is equal to test RMSC, then the model is called as good model. Not best model, guys. Good model. Clearly write clearly good model. If train RMSC, if train RMSC is equal to test RMSC, equal to means not exactly, within a range of plus or minus 5%. Plus or minus 5 percentage. Within a plus or minus 5%. It should be. Right? Now, so for example, if you calculate the train RMSC, what is the train RMSC you got here in the perceptron, I mean ANN with hidden layer of 1. Now, here you got the train RMSC. What is the train RMSC? 5.39. So just open the calculator. Why calculator? Even in the Python only we can write. Okay. Just here, 5.39. Okay. This is your train RMSC, right? Into 0.05. 5% means 0.05. 5.39 into 0.035 means 0.26395, which is round figure is 0.3. Okay. So 5.39, whatever you are having, plus or minus zero point 0.3 should be the test RMSC. Point is clear? Then it is called as a good model. Plus or minus 5%. Either that side or this side. Any side, plus or minus. Now, if anything plus or minus 5% range is there, it is called as good model. For example, if train RMSC is greater than test. Okay, if greater than test RMSC, then this type of model is called as underfitting problem. We call it as underfitting problem. What is meant by underfitting? In this case, what happened basically means training was not good. Training was not good. That is the reason more error. Train RMSC is greater than test RMSC means the example. Let's take an example. Let's 100 is the train RMSC which is greater than 50. 50 or 60 or something. Okay. Now train RMSC is greater than test RMSC in this example. Now what are the train RMSC is greater than test RMSC? Okay. This example, whatever you are having here, the training was not good because error is more. Nah, this is error, right? RMS means error. Error is high means the meaning is training is not good. Whereas testing was good. The performance on the test data is good. Means in the class, if I'm asking assume, let's take an example. I'm explaining in class something, some topic I'm explaining. I'm explaining in class in class some topic. Now what are the topic I'm explaining in the class? I'm asking some questions based on that. Okay, some questions purely based on that. I'm explaining in class some topic and I'm asking some questions, but student no response. Why student is not responding? Because he has not understand the concept. He has not understand. That is the reason I'm explaining the questions. I'm asking some questions also. He's not giving the answer. If he has understood, he will give the answer, right? When they'll not give the answer, means they have not understood. But the same topic, when I keep some in exam, in exam, student performed. student performed well. In exam, he has performed well. But in the classroom, he has not performed well. What is the meaning? Train is bad. The training is bad. After the training, he is understanding the concepts, revising the concepts or something he is going to do. And finally, in the testing, he is going to perform. Sir, what is the problem, sir? Finally, you require exam only, na? He is performing very, very good in the exam. In the class, if he is not performing, what is the problem for you? If he performs, what is the problem? If he not performs, what is the problem? Assume he is not performing in the class, but in exam he is performing, right? Means the problem is if I'm having another student with me, let's take another example where another student is performing in the class, in the exam also. Now, when do the comparison, that person is better or this person is better? In the both of them, exam is performance is common, but some students are going to give in the class also very good answers. Then what is my feeling? Point is clear. So I want a model which can, means I want a student. See, some of the students will be there. There will be slow learners. Every student will not understand in the same level. There might be some students who are the slow learners. Slowly, they will learn the concepts slowly, one by one. And they'll revise the concepts later. After once the class was completed, they'll go to the room and they'll revise and they'll understand more clearly there. After revising only, they'll understand. During the class hours, they'll not understand. When I'm speaking continuously, they'll not understand. Assume. They are called as slow learners. Okay. Now these slow learners, what is the problem, sir? Finally, they are performing now. Though after the class also they are performing. What is the problem is now I want the students who can understand the concepts instantly. Point is clear. Here, I think most of you people has seen this. For every company, they'll keep some kind of aptitude test for the freshers. Most of you are familiar in the college level, when you are in the college level, not in the outside. When we are having the more number of students who are attending for the opening, then to filter them, they will conduct the aptitude test. Generally, that will be done in the colleges or campus placements or some company comes to the Naresh IT also, they will do this. Why they'll do this? Because they'll get 100 applications. They can't do the interview for 100 applications. Na? So to filter some people, they'll apply the aptitude test. Have anyone has noticed that how it is aptitude test is related to Java developer role? How this aptitude is related to some other role? Why IT companies will keep the aptitude test? Is there any connection between the aptitude versus any programming language? Technically, I'm sound in the subject. Why you are conducting aptitude test? Basically, you have to test me in the technical. What are the subject is there? In the subject, you have to ask me. But why you are conducting aptitude test means here the point is very simple. Whoever has more aptitude test score, those people IQ is more. When IQ is more, their learning new things is more. They are going to learn the new things very quickly. That is the reason they'll conduct. The students who performance is aptitude test is more, the students will learn the new things. Once they join in the company now, their performance will be very high. Okay, right? Now coming to this. Okay, so same way, same logic. So when we are having the multiple people or multiple models, I want the model which can perform in the both the cases, not in one case. So when the train RMSE is greater than test RMSE, it is underfitting problem. When train RMSE is less than test RMSE, less than test RMSE, then it is called as overfitting problem. Overfitting means class is clear, class is clear, exam is not good. Means to be more, most of the times we'll get this problem only, guys. 99% in the reality, 99% problem is here. we'll get only 1% of the chances for underfitting problem. 1% chance. 1%. Okay, let us take 10%. 10% projects only will get this one. 90% of the projects you will get the overfitting problem only. What is this overfitting means? Class is very clear. From student point of view, I'm saying class is very clear. Sir, what are the project you have explained is very clear. But when we are trying the new project, it is not clear. Why means the reason behind they are trying to understand the example instead of concept. They are understanding this example. In this case, in this case, in this case, they are saying they are not saying overall point of view, right? Now, so here a class is clear. Class or what are the training is there? The training is clear. But when we are trying on the new data set, it is not clear. Exam is not clear when you are trying on the new one. This we call it as overfitting. Overfitting means training model performance. What are the model is there? Model performed well on trained data. What are the trained data you are having? Model performed well on the trained data. And the same model unable to perform, not performed, or model not performed well on the test data. On the testing data, it is not. Okay, model performed well on the trained data, model not performed well on the test data, which we call it as overfitting problem. Underfitting problem and overfitting problem, right? Is the points are clear, guys, everyone? And coming to the solution, what is the solution when we have the underfitting or overfitting means? Solution for underfitting is you have to add more data. When training is not good, we have to add more data. Okay, everyone please make a note of this. Model not performed well, not performed well on trained data, not performed well on trained data, and model performed well on the test data, which we call it as underfitting problem. And here the solution for this is add more amount of data. Add more amount of data. That is add more records. Add more records. Generally, this type of problem will get when the trained data is very less. I mean, which is less than the 1,000 records. Generally, the students will practice the data sets in the market. What are the general free data sets are available? All these data sets will be less than 1,000 records. So since it is having the less than 1,000 records now, the model will not have that much of performance. Okay. Now, yes, Ganesh is asking, sir, I'm having one question. 1 minute GPT, we upload and we give some prompt related to uploaded data. It gives the correct answer. Give the some info. It is going to work on the large language models. The GPT, what are the GPTs there? It is going to work on the large language models. That is not ANN. It is not ANN. Okay. Everyone is clear here. Now coming to the solution. What is the solution for this one? For overfitting problem, what is the solution, miss? It depends on the algorithm to algorithm. Depends on algorithm. Now, within the ANN, in the ANN, how we are going to improve? Improve accuracy. How we can improve the accuracy in ANN? For example, what are the accuracy we have got in the ANN? How we can improve is first one is We can, okay, we can properly do the data cleaning. Means any mistakes in the data cleaning. A good proper data cleaning. Valid data cleaning. Simple words, valid data cleaning. So you have to cross check earlier what are the data cleaning you have done, whether it is correct way you have done or wrong way you have done or anything. Okay. So first we have to check the valid data cleaning, means our data cleaning is valid or not. Second, after this completed, after valid data cleaning, second option is we can increase the epochs. We can increase epochs. Or third option is increase. Increase the, we are going to increase the some kind of hidden layers. We can add the more hidden layers. Or fourth one is we can increase the batch size. As more number of batches increases, na, automatically still global minimum will be more. Okay. So increase the batch size. Instead of 32 as the batch size, increase the batch size to 64 or 120 or something. 128. Okay. So that is the next one. Now, so increase the batch size, guys. So these are the different options to increase the accuracy in the ANN. Everyone is clear? Increase the epochs, increase the hidden layers, increase the batch size, or any one, not all of them. Either this or this or this. Try any one of one after one after one. Right? Done. Now, sir, how to increase the batch size? How increasing batch size improves performance? Very simple. For example, this one, this one. Okay. Now you are having some diagram like this. In this minimum value, you have to calculate. For example, minimum value you are calculating here this one for this particular batch, for this particular batch, for this particular batch. Now, the more number of batches are there, na, the more number of minimum points will come, right? Local minimum will be more. So within the, for example, if you give the batch size means multiple batches, one batch, second batch like this, na. I will explain in a simple words. For example, uh, you you have conducted one interview. There is one job role and you conducted one interview. For that interview, total 10 people has attended. Out of 10 people, one person is good. Okay, let's take like this. And you are going to select them. If 10 people are not good, then what you are going to do? If 10 people are not good. Or if you can increase more number of people. For example, out of 10, this person is best. For example, 20 people come means in that anything you may get the better person. Na? If 30 people, if you do the interview, you may get the still more better person. Maybe, may not be. Maybe, may not be. As you increase the number of persons like that means there is no restriction. Na? Even 1 crore people, if you do the interview also, you can get. But to some extent, I'm saying as a one of the option. If you try to increase the more number of students, there might be better student who can get the at better package having the good subject. If you can increase the number of people interviewing. Yes or no? Is that clear? Yeah. Next. Uh, Interviewing more people is increasing data records. No, batches. In one, like one student, let us assume as one batch. Okay. Next, sir, after the final RMSC, how to calculate for the future data means how to know the final weights and bias from the code. Here you cannot see the final weights and bias in the final code, but you can predict for the future data. That is possible. How you are going to predict for the future data means like this. Now, first you decide, everyone, first you have to take the model, model one, model. For this model, what is the train accuracy? What is the test accuracy? What is the train and what is the test? Now, if train accuracy is equal to test accuracy only, I told it is called as good model. Now let's take an example, guys. Model 1 has given you like this. Everyone make a note. If model 1 has given you the output of train RMS is 10, test RMS is also 10.2. Good model or bad model? Good or bad? Good model only, na? Now, model 2. You have got 9, 9.1. Good model or bad model? It is also good model. One more model, model 3. 8 and 7.9. Good model or bad model? This is also good model. Like this, multiple good models will be there. A model 4, 29, 14. Good model or bad model? Or for example, instead of big number, I will take small number. This is 5, this is 2. Good model or bad model? Bad model. Now, model number 5, 2, 8. Good model or bad model? Bad model. Now, here you are having the multiple good models are there, multiple bad models are there. Now, out of all of them, which is the best model? Model 1, Model 2, Model 3, Model 4, Model 5. First, good models, how many? 3 are there. Within these 3, which is best? 1, 2, 3, which is best? Means 3 is the best one. Alright. So model 1, model 2, model 3, out of which model 3 is the best one. How model 3 is the best one means out of these 3 models, which has given the least error within the good models only. Though here 2 is there, 5 is there also, I'm not going to consider because they are bad models. Na? Bad models will not even consider. Within the good models only, best model will identify. Okay. Sir, for example, train accuracy is 100%, sir. Means in the class, the student performance is 100%. In the test, his performance is 70%. Good student or bad student means bad student only, obviously. Point is clear. Sir, 100 is there, no, sir. 100 is there also, it is bad only, sir. Both of them should satisfy, na? Not one. Both of them, train and test. Now, within the good models, we are going to find the best model. Best model means how to get the best model. This is called as model selection. Model selection means within the good models, within multiple good models, because we are not going to design one model, we are going to design the multiple models. Within the multiple models, within the multiple good models, the best model is the final model. The final model, what are the final is there? The final model is best model. Everyone is clear? The final model, the final model is the final model, which is the final model means the final not final model, the model which gives which gives least error, least error is the best model, is the best model. So within the good models only, we have to do all these things. It is not comparison between good and bad. Bad is always bad. Just throw it. Everyone is clear? Within the good models only, identify the best model. Now, what are the best model you have identified? For example, here, what is my best model out of these three? NN1, NN2, P model. Out of these three, which is my best model here? NN1. So this NNN model, whatever you have finalized, keep this one side. Now, for the future data, what is the future data? So I'm going to create the future data like this. Import pandas. What are the pandas is there? Pandas as PD and PD dot data frame. PD dot data frame. Now for my future data, I require the data frame. What is the column names? What are the column names, miss? These are the column names. Input column names. Just I'm giving the future data, guys. How the model will be for the future data. So temperature, I'm going to give the temperature as 20, pressure of 1050, and humidity of 50 or 70, and vacuum is 60. What are the vacuum you are having? That is nothing but 60. Now I'm going to create one data frame like this. This is my future data, FUT. Okay, here I have created the future data, but if you have the future data also in the Excel sheet, means bring that Excel sheet, load the Excel sheet. It will simply load the Excel sheet. Here I am just showing as an example. This is my future data for which I have to predict the energy. So using my best model, NN1 dot predict on future. Just I'm going to provide on the future. And what is the estimated value? 473.1159. For the unknown data, it is going to predict with the 473. Sir, what is the possibility of 473 means plus or minus 5, because RMS is there now. RMS is nothing but plus or minus. So plus or minus 5. The future data answer is going to be 473 plus or minus 5. Point is clear, everyone? The value is 473.1159. Just I have converted to list and I have taken from that single value as the output, guys. Okay, everyone. Yes or no? Yes. Can we know the values of weights and biases? No, we cannot know the values of weights and biases. It will store. In an N model, it will store. The values will be stored inside that. Why temperature value was given in the square brackets, not on temperature? Oh, temperature only I have given. Oh, okay, done. So here point is data frame. While creating the data frame, we require the value like this. You know how to create the data frame? So generally for creating the data frame, we are going to use the values like this. Otherwise it will throw the error to create the data frame. In the pandas I have told you, right? Done, right? Uh, Venugopal, we can directly load the data from the SQL means 100% we can load. If you are having the data from the SQL directly we can load. Everyone is clear now? The entire program and how to be predicted on the future data is also clear. Now here just I'm going to keep the heading as prediction, prediction on future data. How it will be predicted on the future data, guys. Prediction on the future data. Done? Now, sir, by using the Streamlight code also we can predict, right? Yes, that is deployment. Streamlight, Flask, all these are deployments, which we are going to discuss in the further. Okay, I'll show you how to deploy in the Streamlight. I'll show you how to deploy in the Flask also, right? Now, next, coming to the next point. Once this is completed, now I'm going to work with the another project, project number 2. Project 1 is completed, guys. What is the project 1? What is the business problem? Estimate the wind energy. Estimate the wind energy. I have estimated, right? Estimate the wind energy based on the conditions. So input data you are providing, and based on that I'm predicting the output. It's completed. This is only my model. Now in the model, just you are going to share the input data. What are the input data you are going to provide? You may change the values here. And obviously the person is going to execute all these cells means no need. Here what are the best model is there na? The best model we are going to save it directly. And we are going to use the deployment. During the deployment time, I'll tell you how to save and how to use the model. Okay. Now, coming to this project number 2. This is classification project. One is regression project and second one is classification project. Right? Now, so what are the classification project is there? Just a minute. Can you call the admin once? అడ్మిన్ నాబాబ్ సార్ ఉన్నారా? నాబాబ్ సార్ పిలువ. Okay, guys. Now, model project number two is classification project, where we are having the Chen modeling. Now, what is meant by Chen modeling project means whether the person will exit the company. Churn. Churn means exit. Whether the person will exit or not. Okay. Generally, we call it as HR analytics project. This type of projects. Even in the companies also, inside the companies also, we'll see that whether these people will exit the companies or not. HRs will observe this, right? Now, here we are having the different column names. But coming to this example, whether the customer will exit or not from the bank. This is basically from the bank. Okay, the data set whatever we are having, it is banking. Whether the customer will exit the bank or not. So row ID number, customer ID, and surname, credit score. What is the column name? Credit score. Credit score means, as we know, what are the loan amount they are going to take and if they are repaying on time or not. Whoever the persons are repaying the credit on time, their score will be very high. Who are not repaying on time, the score will be comparatively less. Next, geography. Geography means from which place. From which place they are doing this. Next, gender. What are the gender column? And age of the person. Tenure. What are the tenure? And balance. Balance means in that bank account, what is the balance? Generally, the people who are having the low credit score and zero balance or less amount of balance, what they'll do is generally they'll exit the companies. I mean, from the bank account because they're not maintain the properly the balance. No? Now, number of products. How many number of products they are holding from the bank? So just here, first I'm going to take the uh, column names. First, as I've told you, data understanding. In the data understanding, first I'm going to understand the column names. Along with the column names, as I've told you, you have to observe their unique values. That is credit score. What is the credit score? Unique values are there. Next, geography. What are the unique values are there in the geography means France, Spain, and Germany. Now, what is the meaning of geography means from which country they belongs to? Gender, male or female. Next, tenure. Tenure is from how many years they are maintaining the relationship with the bank. How many times, how many years they are maintaining the relation. Okay, age of the person already we know. Tenure. Balance. What is the balance amount? Number of products. How many number of products they are having? Has credit card or not? Has CR card. CR card means credit card. Sir, how you know means I told you na nomenclature will be provided. Here for you, the nomenclature is also me only. I am only giving the things. But in the company, you'll get a separately data nomenclature. Now, is active member. Is active means presently using that one or not. That is called as active member. Right? Next, estimated salary. Estimated salary is nothing but because banks never know the what is the salary unless it is a salary account. If it is the salary account means automatically the company will create the salary in the bank account and others will understand. But if whenever the company doesn't create the salary in the account, based on our balance, they will estimate. The company people will estimate that one. That is nothing but regression project. Estimating the salary is nothing but regression project again. Now, which type of people has got exited? Which type of people has got exited? Now here within the exit, what are the unique values are there means zeros and ones. Only two categories are there. One is whether the person has got exit, yes or no. One means yes, the no zero means no. The person has not exit. Now here the person, okay, he has got exit from the bank. Why means because he is maintaining the low balance, zero. Some people are having the good amount of balance also, their credit score might be low. Okay. So now here as an example, order the credit score, credit card and everything. Okay. Holding the has credit card or not, yes or no. So if the person has multiple products from the bank like credit card, personal loan, vehicle loan, or home loan account. Like this, if they're having the multiple products now, automatically they'll continue from with the bank. That is the reason banks will always give the some pre-approved offers to their customers to attract them, to make sure that they are in the bank only. That is one of the reason. Second is because already they know about the customer and how he's maintaining the balance account and everything. So obviously, since they're already familiar with that person, so comparatively the risk is comparatively less instead of outsider. So always the banks will give the preference for their customers to give some kind of approved pre-approved loans or something. Now coming to the first, after doing the data understanding along with the data exploration. Did I completed data cleaning and data exploration? Everyone? Anything is pending? Every column name and what are the internal values? Did I explain or not? Everyone please confirm me. Done. Now, so here data cleaning, data understanding and data exploration. Now, after doing the data cleaning and data exploration, next one is data cleaning. Now I'm going to clean the data. Now in this data, I'm going to remove the row number, customer ID and surname. Why I'm removing? What is the reason? I told you for every data cleaning, you have to tell me the reason why. I want the reason why. What is the reason, guys? Everyone, could you tell me? Yes, every record is going to be the unique value. One row number means every record. Row ID number 1, ID 2, ID 3, ID 4, like that. One row will have one number automatically. Okay. So every row will have one unique value. Na? So since there is no difference, okay, the credit score and all this unique values, tenure, having the credit card or not, and df dot drop. What are the drop is there? Row number, customer ID, and surname. For these three, every record will have the unique values. So that is the reason I'm dropping. Now total, how many columns they have given for me? 14. Raw data consists of 14. Out of 13 of them are input, one is output. Out of 13, 3 of them I have dropped, minus 3. 3 of them I'm dropping. That is 10. Now balance only 10 is there. Now out of these 10, now when I observe the geography, what are the geography column is there? Now this geography column has 3 unique values. What are the 3 unique values means? France, Spain and Germany. Now automatically how many new columns will be created when I done the dummy encoding? 2 new columns will be created. So plus 2. Okay. 2 new columns will be added. And one original column also will be removed, right? One will be removed, two will be added. Two will be added, one will be removed. In the dummy variables, we have to total, for example, this is as it is like this. France, Spain, and Germany. Out of three, one of them has to be dropped. So balance two will come. Original column also will be dropped. So original is dropped and additional is dropped. So net, how many will be there? 2 minus 1. This is for geography. Coming to the gender. For gender, when it is converted to dummy variable, male and female, Out of male and female, one of them you are going to drop. One you have dropped means one you are going to add. One will be added at the same time original column will be deleted. That is minus one. Original will be deleted, right? So after deleting like this, original is deleted and once everything was done, you are having 10. For 10 plus 2 minus 1 plus 1 minus 1. Total how many will be added overall? You are going to get 11. Point is clear? After doing the data wrangling, that is data wrangling. So original data, raw data consists of 14. Out of 13 input, one is output. But once the entire data cleaning was completed, finally I will have the only 11. 11 only will be left. So here see, I'm going to take the input variables and I'm applying the dummy variables. Okay, now when I apply the dummy variables, if I open my X, can you see everyone? So here geography Germany and Spain is there. France was removed. And within the gender of male and female, female was removed. So three new columns are added, two original columns are deleted. So net to how many columns net? 11. Everyone is clear? Now I'm going to use the train test split. Now earlier for regression project, sir, you have taken more amount of time on the regression project. Now you are going to take the less time in the classification. I am assuming that you are going to take the less time. Means here same code was there for multiple times. Now should I explain in the last class for the first time you are saying the train test split? I have explained very clearly. Should I explain now also? Any code difference is there in the train test split? Now also should I explain? No, right? Automatically the time will be saved now. Understood or not? Now, so next here, automatically when the times are going to get saved every time, then automatically the second project will be completed in the less time only. First project only will take more time because many things have to be introduced for the first time. But second project, third project, same things will be there. Almost similar will be there. Yeah. Whenever you apply the max, that is sigma wxi plus b, automatically the boolean has to be converted to int in the typecasting I told you. When you are applying the arithmetic operators, anyone can you tell me true plus false? What is the answer? What is the answer of true plus false? Plus. It is not true or false. True or false means true. True and false means false. That is logical operator. I'm asking arithmetic operator. What is the answer of arithmetic operator? It is going to give the 1 because 1 plus 0, 1 is the output. Why it is going to give the 1? Because whenever there is a plus symbol or multiplication symbol or something, the boolean will be converted automatically to the int. So obviously these values, once you send into the neural network, sigma wxi plus b is multiplication only now. Either multiplication or addition has to be done. For multiplication and addition, automatically this will be converted to int values, right? Though they are in the boolean also. Understood, Suresh? Yeah. Next, I'm going to do the scaling. Sir, but in the last class you have not done the scaling, no sir. Suddenly why you are doing the scaling right now in this class, miss? Reason is very simple. Why I'm doing the scaling for classification project is here the values in credit score the numerical numbers are small numbers are there. Here big numbers are there. When we are having the high magnitude and low magnitude values, in that case, we have to do the scaling. Point is clear? Everyone, understood or not? In the last example, there is no big numbers, there is no small numbers. Almost every number in the same range only. Every column numbers are in the same range. That is the reason we have not done the scaling. But whereas coming to this example, As we are having this two columns, two numerical columns with big, big numbers, remaining numerical columns are having the small numbers. So that is the reason we are doing the scaling here. And already I told you scaling, standard scaler and fit and transform and everything. Already this was completed. Now, whereas fit and transform, you're going to do only on the trained data. Testing on the test data, you are just going to the transform. Sir, why you transform only? Why you are not going to use here fit word means fit means calculate. Calculations always should be done only on the trained data. Means whatever you want to explain, you have to explain only in the class. Once the exam question paper was given, you cannot ask the questions. I should not explain the things. If I come to the examination hall and if I explain this question paper, Amma, this one is this one, ma, do you think that we have discussed in this class? Write that one. If I say like this, then what is the use of testing? There is no use of testing, right? Everyone, understood? So fitting has to be done. Wherever the word fit comes, na, fit will be applied only on the trained datas. Never it has to be applied on the test data. The fit word only never has to be applied. Now, for this particular project also, now I'm going to do the modeling. As already you know what to be done. Modeling means what? What is meant by modeling? Design. Next, after design, what is the second step? Fit. After fit, what is the next step? Predict. After predict, what is the next step? Evaluate. Total four. Just now we have completed here. Okay, same four we are going to do here. Design, fit, predict, and evaluate. Same thing. Same codes, same thing. Now, first only you know that how many layers has to be added. Everyone knows anything? No. What from where we have to start? Zero hidden layers only we have to start. So I'm going to take here zero hidden layers. Zero. That is nothing but number of units is equal to zero. Now, instead of doing this one, so I'm deleting the code entirely for you. Earlier, whatever here we have written in the regression project, that code only I'll copy directly in front of you so that you'll understand the difference. Okay. Now, what is the difference between this code versus this code? So here first I'm going to import the sequential and dense common where you are going to import the TensorFlow and Keras everything. Same way import the sequence and dense also. Now neural network design of the perceptron model. This is perceptron model, na? Perceptron model. Within the perceptron model, in the regression project, what is the name we have given? P model. So I'm using here P model is equal to sequential. Now P model dot add dense. Now how many input dimensions should be there? 11. Why 11 now? Because after doing the data cleaning and data wrangling, finally we have got the 11 columns. Sir, just I want to check, sir. Okay, check. Just open the extrain. Okay, or here also just ask extrain. What are the extrain dot shape? What is the number of records means 8,000. Columns are 11. 11 columns. The number of records are 8,000. Why 8,000 sir? 10,000 in the 10,000, 8,000 records are went for the training, 2,000 records for the testing. 80 is to 20 ratio. Na? Everyone is clear? Done? Now, so here first I'm going to take the 11 input dimensions. For my 11 input dimensions, what are I have considered? Now, what are the input dimensions 11 I have considered with number of units is equal to 1. Sir, again, y is equal to 1? Because it is a binary classification project. For binary classification project also, output number of units will be 1 only. For multi-class classification project, it is different. Now, for binary classification project, units is equal to 1. Kernel initializer is equal to uniform, and activation function, what I have to use here? Sigmoid. That is the difference. Sigmoid is the activation function which I have to use. Here I have used the activation function ReLU in the regression project. Here I am going to use the sigmoid for binary classification project. Next, compiler is equal to Adam. Loss is equal to error. But here I'm not going to calculate the loss as error because it is not number. Number minus number, error will come. But it is not error, misclassification rate. So another name of misclassification rate is binary cross entropy. Binary cross entropy means indirectly it is going to calculate the misclassification rate. And matrix is equal to accuracy. Now what is meant by matrix is equal to accuracy? Means the higher the accuracy it is going to provide. Right? Now training with ANN.fit on xtrain comma ytrain, epochs is equal to 100, batch size is equal to 32. It is going to give the batch size of 32 and epochs of 100. Now same thing. Now here see it is throwing the error that what is ANN. So what is the name I have given? P model. So I'm going to compile with the P model only. P model dot fit. Now tell me guys, what is the difference you have observed? This is misclassification rate. Now tell me, what is the observation you have made when compared to regression project versus binary classification project? Means only output layer, what are the output layer activation function is going to be sigmoid. Instead of ReLU, sigmoid. Other than that, everything is same. Everyone is clear? Yes or no? Just it is going to calculate. Let's cross check with the number of epochs. Once epochs are completed, after the epochs are completed, what is the next step, guys? What is the next step after the epochs are completed? Prediction and evaluation. So you're going to predict on the X-train data, predict on X-test data, and from that we are going to calculate the accuracies. Train accuracy, test accuracy. Accuracy now we are going to calculate. It is not with respect to error. We are going to calculate the accuracy. That is P model. What are the P model is there? P model dot predict on X train. Similarly, P model dot predict on X test. Now, what is this 0.5, sir? Because sigmoid activation function will give the value between 0 to 1. Probability na. If you open your activation function notes, in that I told you sigmoid will give the probability as the output. So what are the probability it has given? Probability means nothing but value between 0 to 1. Any value between 0 to 1. Any value between 0 to 1 like 0.1, 0.2, 0.3, 0.24, 0.17 something. Now whichever the value is greater than 50%, that is 0.5, it has to be considered as round figure as 1. Whichever the value is less than 0.5, it has to be considered as round figure of 0. Because our output is zeros or ones now. Or what are the output we are having? The output is 0 and 1. So predicted values also should be 0 or 1 only. So to get the predicted values also 0 or 1, just we are going to use the more than 0.5. Wherever the more than 0.5 is there, that. So this is the train accuracy and test accuracy, guys. Everyone is clear up to here? Anyone has any questions, please ask. What are the questions you are having? Everyone is clear, guys? If no questions from here, we'll continue in the tomorrow's class. Project was not completed. Still slightly is there. At the same time, we have to add the hidden layers for this one also. We'll discuss from here in the tomorrow's class. If you're having any questions, you can ask. Now tomorrow we are having the class. January 1st is working day for Naresh IT and we are having the class. Regular class is there. Online students can attend online, offline students can attend offline. Done. Everyone please go through the previous classes and properly make sure everything. Yeah. Now coming to the next question, as one of the student is asking, Suresh, Jupyter Notebook versus tools like PyCharm, which one is preferred in the real time? Jupyter Notebook only is preferred for the ML and AI engineers. Python developers will use the PyCharm. Yarlagadda Venkat Nagarjuna. Already yesterday itself it was uploaded. Cross check once. Both the codes are uploaded along with the data sets. Check once in your Google Drive. ANN code for regression. That is the PDF. Yesterday's class what was discussed. I mean video. Okay, you're asking the video now. Uh, you have, for video related queries, you have to contact the admin. Okay, done. Thank you guys.